Now let us see the functionality of electric motor using the Fleming's left-hand rule. An electric motor is a rotating device that converts electrical energy to mechanical energy. Electric motor is used as an important component in electric fans, refrigerators, mixers, washing machines, computers, MP3 players, etc. An electric motor consists of a rectangular coil ABCD, two poles of a magnetic field, brushes X and Y, split rings P and Q, switch, battery and axle. Arm A, B and CD are perpendicular to the direction of the magnetic field. Switch on so that current enters from the source battery through conducting brush X, and flows back to the battery through brush Y. Let us list out the findings for the test. The first finding is, the current in arm AB of the coil, flows from A to B. In arm CD it flows from C to D, which is opposite to the direction of current through arm AB. The second finding is, on applying Fleming's left-hand rule for the direction of force, on a current-carrying conductor in a magnetic field, that is the force acting on arm AB pushes it downwards, while the force acting on arm CD pushes it upwards. The third finding is, such the coil and the axle, mounted free to turn about in axis, rotate anti-clockwise. The fourth finding is, at half rotation, Q makes contact with the brush X, and P with brush Y. Therefore the current in the coil, gets reversed and flows along the path DCBA. The fifth finding is, in electric motors, the split ring acts as a commutator. A device that reverses the direction of flow of current, through a circuit is called a commutator. The sixth finding is, the reversal of current also reverses the direction of force, acting on the two arms AB and CD. Thus the arm AB of the coil, that was earlier pushed down is now pushed up, and the arm CD previously pushed up is now pushed down. Therefore the coil and the axle rotate half a turn more in the same direction. The seventh finding is, the reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil, and to the axle. The commercial motor uses, an electromagnet in place of permanent magnet. The large number of turns of the conducting wire in the current-carrying coil, and soft iron core on which the coil is wound. Let us summarize the points that we have covered in this lesson. Magnetic field is generated when electrical current is passed through electric conductor. The magnetic field is a vector, that is both magnitude and direction. Like poles repel each other. Unlike poles attract each other. Fleming's left-hand rule defines relation between current, magnetic field and direction of motion. If current flowing in a conductor and magnetic fields are at right angles with each other, then the direction of motion of conductor will be at right angles with both the direction of flow of current and the magnetic field. If the direction of flow of current in a conductor is reversed, the direction of motion of the conductor will be reversed. Fleming's left-hand rule is used in all kinds of electric motors. Remember these important points. In household circuits all electrical appliances are connected in parallel. Larger the number of turns for coil wire, greater the magnetism is produced. Higher current gives higher magnetism. An electric motor works on the principle of force experienced by a current-carrying conductor in a magnetic field. A circular coil carrying current is similar to magnet. The core of a solenoid acts as an electromagnet. Fleming's left-hand rule is used in electric motors for converting the electrical energy into mechanical energy. A galvanometer is an instrument that can detect the presence of a current in a circuit. The pointer remains at zero, for zero current flowing through it. It can deflect either to the left or to the right of the zero mark depending on the direction of current.